August 17th, 1943, Schweinfurt, Germany. The technical officers from Luftwaffe Erprobungsstelle Rechlin gathered around the wreckage of B-17 Farad's serial number 42-30381, shot down 12 hours earlier during the deepest American bomber raid into German territory to date. The flying fortress lay scattered across a farm field, its aluminum skin torn and punctured by more than 80 cannon strikes from Messerschmitt Bf 109 fighters. But what caught the attention of Major Hans Werner Lerche, the Luftwaffe's senior test pilot and technical evaluator, wasn't the damage the Germans had inflicted. It was the ammunition still loaded in the bombers' defensive gun positions. Belts of .50 caliber Browning ammunition, manufactured at facilities across America, each round precisely machined, each cartridge identical to the thousands of others recovered from dozens of downed American bombers that summer. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The rounds themselves told a story that German ordnance experts were only beginning to understand. A story about industrial capacity so vast, it could produce millions of rounds per month with quality control so rigorous that every cartridge performed identically. A story about manufacturing philosophy so fundamentally different from German approaches that it revealed a gap not in engineering knowledge, but in something far more difficult to overcome: the systematic application of mass production principles to military ordnance. This ammunition, standardized across every American aircraft and ground weapon using the .50 caliber cartridge, represented an industrial achievement Germany simply could not match. The mathematics of the air war were about to be rewritten, not through superior tactics or aircraft design, but through the relentless consistency of American ammunition production that German industry had never prioritized and could no longer hope to achieve. The belt of .50 caliber ammunition extracted from that crashed B-17's ball turret bore markings that identified its origin: LC-43, indicating manufacture at Lake City Ordnance Plant in Independence, Missouri, during 1943. The rounds measured precisely 5.45 inches in length. The brass cases showed no variations in dimensions. The projectiles seated to identical depths, the powder charges, invisible inside the sealed brass, conformed to specifications so tight that muzzle velocities varied by less than 50 feet per second between rounds, a tolerance German ammunition manufacturers considered impossible to achieve in mass production. German technical officers had been examining captured American ammunition since 1942, when the first B-17 seconds began operations over occupied Europe. Early assessments had focused on the obvious characteristics: the steel armor-piercing cores in M2AP rounds, the incendiary composition in M8 API ammunition, the pyrotechnic mixtures in tracer variants. These were features German ammunition possessed as well, though often with different specific compositions. What German experts gradually came to understand through 1943, however, was that the ammunition's most significant advantage lay not in any single technical feature, but in the absolute consistency of manufacture across millions of rounds produced at multiple facilities. American bombers carried ammunition manufactured at Lake City, Twin Cities, Lowell, Des Moines, Salt Lake City, and Milwaukee ordnance plants. Rounds from any facility functioned identically in any weapon. Parts were genuinely interchangeable, not merely theoretically so. This interchangeability, routine in American automotive industry since the 1920s, remained largely theoretical in German ammunition production, where each manufacturer introduced subtle variations that prevented true universal compatibility. A German MG 131 machine gun might function perfectly with ammunition from one factory, but experience increased jam rates with ammunition from another, despite both nominally meeting the same specifications. The technical evaluation facility at Rechlin, located approximately 60 miles north of Berlin, served as the Luftwaffe's primary testing center for both German and captured Allied equipment. Here, meticulous engineers tested everything from complete aircraft to individual components, documenting their findings in exhaustive technical reports. The .50 caliber ammunition recovered from American bombers throughout 1942 and 43 underwent systematic evaluation, designed to identify any weaknesses or manufacturing defects that German intelligence could exploit. Test engineers fired thousands of captured rounds through test fixtures, measuring chamber pressures, recording velocities, analyzing failure modes, documenting every characteristic with scientific rigor. The results contradicted everything German ammunition doctrine had accepted about the necessary trade-offs between production volume and quality control. American ammunition performed to specification in 99.9% of rounds tested. Propellant charges showed remarkable uniformity. Primer compounds ignited with absolute reliability. Projectiles maintained consistent trajectories shot after shot. The entire production system reflected a design philosophy that prioritized dependability over theoretical optimization. August 1943 brought expanded testing programs as Luftwaffe bomber losses mounted to unsustainable levels. German intelligence reports from fighter units attacking American bomber formations documented a disturbing pattern. Defensive fire from B-17 and B-24 gunners, while rarely scoring confirmed kills, was forcing German fighters to attack from disadvantageous angles, reducing time in firing position, and most critically, maintaining such sustained volume of fire that German pilots could not press attacks home without accepting catastrophic risk. The defensive armament examination revealed design philosophy differences that explained much about American versus German approaches to aerial warfare. A late-model B-17G carried 1350 caliber Browning M2 machine guns positioned to provide overlapping fields of fire from every approach angle. Each gun fed from ammunition supplies ranging from 270 to 400 rounds, depending on mounting position. Total ammunition capacity exceeded 6,000 rounds distributed across all defensive positions. In a 5-minute engagement, a B-17's defensive gunners could maintain nearly continuous fire, expending their entire ammunition load if necessary. German fighters attacking bomber formations faced not individual aircraft, but interlocking defensive fire from multiple bombers in combat box formations, creating zones of concentrated 50 caliber fire that no aircraft could survive for extended periods. The B-17's defensive armament demonstrated what German fighter pilots had learned through bitter experience during 1943. American bombers didn't need to shoot down German fighters to be effective defensively. They needed to force German pilots to attack quickly from difficult angles, limiting time in firing position, reducing accuracy, preventing the sustained cannon fire required to destroy the heavily armored bombers. German fighter tactics had evolved throughout 1943 in response to this defensive firepower. Head-on attacks, approaching the B-17's weakest defensive sector, became standard procedure. Focke-Wulf, 190 pilots, developed high-speed slashing attacks that minimized exposure to defensive fire. Messerschmitt, 110 heavy fighters, stood off at ranges beyond effective 50 caliber reach and launched Werfer-Granit 21 cm rockets into bomber formations. Each tactic represented adaptation to the reality that German fighters could not survive prolonged exposure to massed 50 caliber defensive fire. The ammunition quality enabled American gunners to maintain accurate fire even at extreme ranges, forcing German pilots to either accept the defensive fire or break off attacks before achieving decisive results. September 6, 1943. Stuttgart mission. 338 B-17 seconds penetrated German airspace without fighter escort beyond the German border. Luftwaffe fighter units responded with maximum effort, launching more than 300 interceptors against the bomber stream. The engagement lasted approximately 45 minutes, as German fighters pressed repeated attacks against the American formation. Post-mission analysis by both sides revealed the grinding arithmetic of the daylight bombing campaign. American bombers lost 45 aircraft, representing 13% of the attacking force. German fighters destroyed most of these bombers through concentrated cannon fire during head-on attacks that minimized exposure to defensive guns. But the cost to the Luftwaffe was far higher than American losses would suggest. Luftwaffe maintenance records from September 6 documented that German fighter units expended their entire ammunition supplies during the engagement. Many Bf 109 fighters returned with empty ammunition bays after firing all 200 rounds for their 30mm Mk108 cannon and both belts for their 13mm MG-131 machine guns. FW-190 pilots similarly exhausted their ammunition, firing every available round during multiple attack passes. The American bombers, by contrast, returned with substantial remaining ammunition in most defensive positions. Gunners had fired selectively, targeting fighters during attack runs but conserving ammunition between engagements. The consistency of the .50 caliber ammunition meant gunners could trust their weapons to function when needed, eliminating the need to fire continuously to verify weapons remained operational. This ammunition conservation, possible only because of the absolute reliability American ammunition provided, gave American defensive gunners a critical advantage. German pilots attacking bomber formations late in an engagement faced the same defensive firepower as those attacking early because American ammunition supplies hadn't been depleted through malfunction clearing or reliability testing. By October 1943, Luftwaffe operations staff maintained detailed statistical analysis of bomber combat. The numbers told an increasingly grim story about the sustainability of German fighter operations against American daylight raids. German fighters were shooting down bombers at rates that would have been decisive in 1942, but American production was replacing bomber losses faster than German factories could replace fighters, and, more critically, American crews were being trained faster than German pilot training schools could replace experienced fighter pilots. The ammunition factor contributed directly to this attrition disparity. American bombers could sustain defensive operations mission after mission because their ammunition worked correctly, requiring minimal maintenance, functioning reliably under all conditions. German fighters required constant attention to weapons systems, with ammunition feeding problems, extraction failures, and primer malfunctions occurring at rates that reduced operational readiness across the fighter force. November 1943 brought reports from Major Anton Haeckel, who would end the war credited with 192 victories, describing the difficulty of attacking B-17 formations from any angle. If one came in from the rear, there was a long period, closing from 1,000 meters to our firing range of 400 meters, when the bombers were firing at us, but we could not fire at them. This was a very dangerous time, and we lost a lot of aircraft trying to attack that way. The head-on attack provided better odds, since bomber forward-firing defensive armament was more limited and armor less effective. Destroying a bomber from head-on could be achieved with 4 or 5 20mm hits, according to Luftwaffe studies of combat camera footage and wreckage examination. However, this approach required skillful flying and accurate shooting during the brief seconds when the fighter closed from beyond bomber gun range to minimum safe separation. The best German pilots achieved high victory scores using such tactics, but pilots of average ability struggled to score hits during the limited firing window head-on attacks provided. The fundamental problem remained that Luftwaffe ammunition capacity couldn't sustain prolonged engagements. A Bf 109G6 carried just 230 rounds of 30mm ammunition and 600 rounds of 13mm, enough for approximately 15 seconds of sustained fire from all weapons simultaneously. American defensive gunners, by contrast, could maintain fire for minutes rather than seconds. A ball turret gunner in a B-17 controlled twin .50 caliber machine guns, each loaded with approximately 550 rounds. At the standard rate of fire of 750 rounds per minute, this provided roughly 44 seconds of continuous fire per gun, or nearly 90 seconds total, if fired alternately to avoid overheating. This sustained fire capability, multiplied across 10 defensive gun positions on a B-17G, created an almost impenetrable defensive shield when multiple bombers flew in formation. German fighters attacking combat box formations faced not one bomber's defensive fire, but coordinated fire from 18 to 21 aircraft simultaneously, concentrating thousands of rounds per minute into the approach paths German fighters had to use. December 1943 brought systematic evaluation of ammunition reliability by both air forces. American ordnance officers examining returned bombers documented malfunction rates below 0.1% for .50 caliber ammunition fired in combat. Out of more than 1 million rounds expended during a typical month of bomber operations, fewer than 1,000 exhibited any malfunction, and most of those were minor issues like failure to extract that cruise cleared in seconds. German ammunition quality control, by comparison, accepted malfunction rates 10 times higher than American standards. Luftwaffe technical orders acknowledged that pilots should expect occasional feeding problems, extraction failures, or misfires during combat operations. Fighters were designed with systems to clear malfunctions in flight, accepting that ammunition reliability would never match theoretical perfection. This acceptance of imperfection reflected German manufacturing reality. Precision production required skilled workers using specialized equipment under controlled conditions. Germany's industrial base could produce excellent ammunition in moderate quantities from dedicated facilities, but scaling production to American levels while maintaining quality proved impossible given Germany's labor shortages, raw material constraints, and Allied strategic bombing of critical manufacturing infrastructure. The Lake City Ordnance Plant in Missouri alone produced more ammunition monthly during 1943 than Germany's entire small arms ammunition production across all facilities combined. Lake City achieved this output through automated production lines that minimized human error, using American automotive manufacturing principles developed over decades of civilian production. The plant employed predominantly female workers with minimal technical training, operating machinery designed for simplicity and reliability. Each round passed through multiple quality control checkpoints, using go divided by no-go gauges and statistical sampling that identified problems before they affected production. Rejected ammunition was melted down and remanufactured, ensuring that substandard rounds never reached operational units. German ammunition factories, by contrast, relied heavily on skilled craftsmen, performing manual operations that automated systems could not easily replace. Quality control depended on worker expertise rather than systematic measurement, creating batch-to-batch variations that American production eliminated through statistical process control. January 1944 brought expanded American bomber operations as P-51 Mustang fighters began providing escort deep into German territory. The psychological impact on Luftwaffe fighter pilots was profound. Previously, German fighters had avoided sustained combat with bomber formations, making high-speed attacks and disengaging before defensive fire became too intense. With American escorts present, German fighters had to either accept extended combat or concede air superiority. In these prolonged engagements, ammunition reliability determined survival. American fighters carried approximately 2,000 rounds total across 6 .50 caliber machine guns, providing approximately 27 seconds of continuous fire. German fighters carried less ammunition for their heavier weapons but faced the same fundamental problem. Once ammunition was expended, they became defenseless. The difference was that American ammunition worked as designed every time. Pilots could trust their weapons to function when squeezing the trigger. German pilots developed habits of firing short bursts and checking weapons function between engagements, compensating for reliability issues through careful ammunition management that American pilots never needed to consider. February 1944 marked the beginning of Big Week, a concentrated series of raids targeting German aircraft production facilities. The Cannon operation demonstrated conclusively that American bomber formations could survive and accomplish missions despite heavy opposition, provided they maintained formation integrity and received fighter escort for portions of the mission where defensive firepower alone proved insufficient. During these raids, B-17 and B-24 gunners expended more ammunition than in any previous series of operations, some bombers returning with ammunition bays nearly empty after defending against repeated attacks over several hours. The .50 caliber Brownings functioned without pause, firing thousands of rounds through barrels that glowed red from continuous use, but never failed mechanically. German maintenance crews examining fighters that survived these engagements found ammunition-related failures in approximately 15% of aircraft. Weapon stoppages, feed problems, and extraction failures had forced pilots to break off attacks or reduced available firepower at critical moments. The cumulative effect of these small reliability differences, multiplied across hundreds of aircraft and dozens of missions, created a persistent advantage for American forces that German tactical skill could not overcome. The ammunition story continued throughout 1944 and into 1945, but the fundamental pattern was established by spring 1944. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. American .50 caliber ammunition, produced by the tens of millions at automated factories across the United States, maintained absolute reliability that German production could never match. This reliability enabled defensive tactics that protected bomber formations, sustained fighter operations that achieved air superiority, and ultimately contributed to the systematic destruction of Germany's ability to defend its airspace. The captured ammunition examined at Rechlin in August 1943 had revealed a truth German engineers understood, but German industry could not address. America had achieved industrial maturity in ammunition production that represented decades of automotive manufacturing experience applied to military ordnance. The consistency wasn't achieved through superior metallurgy or advanced chemistry, but through systematic application of quality control principles and automated production methods that German wartime industry lacked the resources to implement. March 1944 brought comprehensive technical reports from Rechlin that circulated through Luftwaffe commands and the Reich Ministry of Armaments. These documents, intended for senior officers and industrial officials, painted a sobering picture of comparative ammunition capabilities. The reports acknowledged what field commanders had known for months. American ammunition demonstrated industrial excellence that Germany fundamentally lacked despite superior theoretical knowledge in some areas of ordnance design. The testing protocols had been exhaustive. Engineers fired captured .50 caliber ammunition through specialized test fixtures that measured chamber pressure with precision instruments. They recorded velocities using chronographs positioned at multiple distances from the muzzle. They examined fired cartridge cases under magnification, looking for signs of excessive pressure, case head separation, or primer failures. They sectioned unfired rounds to analyze powder composition, measure charge weights, and inspect bullet construction. Every test confirmed the same fundamental characteristic: exceptional consistency derived from rigorous manufacturing process control. Powder charges varied by less than 1/10 of 1 grain between rounds from the same production lot. Primer compounds showed identical sensitivity across thousands of samples. Bullet weights remained within tolerances so tight that German manufacturers considered them impossible to achieve in volume production. The ballistic consistency translated directly into accuracy advantages. American gunners could rely on ammunition to impact where aimed, shot after shot, without the trajectory variations that German ammunition exhibited. At combat ranges of 400 to 800 meters, this consistency meant the difference between rounds grouping tightly around the aim point versus dispersing across a pattern several meters wide. German 13mm and 20mm ammunition showed far greater variability. Velocity spreads of 200 feet per second between rounds were considered normal and acceptable. This variability forced German pilots to compensate through experience and skill, learning to judge where rounds would actually impact versus where the gun sight indicated they should go. The armor-piercing characteristics of American M2 AP and M8 API rounds particularly impressed German evaluators. The steel cores, heat-treated to precise hardness specifications, penetrated armor plate with remarkable consistency. German testing against captured American armor demonstrated that M2 AP rounds could perforate 22 mm of face-hardened steel at 100 yards with near-perfect reliability. More significantly, the incendiary composition in M8 API rounds functioned exactly as designed, igniting on impact with hard targets and spreading flame across the target surface. German intelligence had captured numerous examples of American bomber gun camera footage showing M8 API rounds, striking German fighters and immediately producing the characteristic flash of incendiary ignition. These incendiary effects were not random or occasional. They occurred with every hit against suitable targets, demonstrating that the incendiary composition had been manufactured to specifications so precise that every round performed identically. German incendiary ammunition achieved similar effects, but with less consistency due to variations in composition mixture and loading density between production batches. April 1944 marked the beginning of sustained American escort fighter operations throughout German airspace. P-51 Mustangs, each carrying approximately 2,000 rounds of 50 caliber ammunition distributed across 6 wing-mounted machine guns, accompanied bomber formations from England to targets anywhere in Germany and back. The psychological impact on Luftwaffe fighter forces was devastating. German pilots, who had survived months of combat against bomber formations, now faced American fighters that could match or exceed the performance of Bf-109 and FW-190 aircraft, while carrying ammunition loads that provided more than twice the firing time of German fighters. A P-51 pilot could maintain sustained fire for nearly 30 seconds, far longer than the 15 seconds of ammunition German fighters carried. This endurance advantage meant American fighters could spray areas with suppressive fire, forcing German fighters to maneuver defensively and break off attacks. German pilots developed an acute awareness that every second spent in combat depleted irreplaceable ammunition, while American pilots could afford to fire speculatively, using ammunition volume to compensate for any accuracy limitations. Oberleutnant Heinz Nock, commanding officer of Sturmgruppe 1 and a veteran with 33 confirmed victories, wrote in his combat diary during April 1944 about the futility of attacking bomber formations protected by P-51 escorts. The Mustangs appear everywhere, always at the critical moment. Their ammunition seems endless. We make one firing pass and must break away to avoid their pursuing fire. They follow us down, shooting continuously, never seeming to run dry. Noak's observations reflected the mathematical reality of the air war by mid-1944. American forces had achieved ammunition superiority through industrial capacity that produced rounds faster than combat consumed them. German ammunition production, constrained by raw material shortages and Allied bombing of manufacturing facilities, could barely replace combat expenditure, leaving no reserves for training or tactical experimentation. May 1944 brought the final phase of Germany's air defense crisis. Allied air superiority was now absolute over most of Germany during daylight hours. Luftwaffe fighter units carefully husbanded remaining aircraft and ammunition, launching only when conditions seemed favorable for successful interception without prohibitive losses. These selective engagements demonstrated that German fighters could still achieve tactical victories when circumstances aligned. On May 9th, Luftwaffe fighters destroyed 25 bombers from a force attacking targets in eastern Germany. On May 24th, German fighters shot down 33 bombers attacking Berlin. These successes, however, came at costs the Luftwaffe could no longer sustain. German ammunition production statistics from May 1944 revealed the industrial collapse that Allied strategic bombing had achieved. Total production of 13mm and 20mm ammunition had fallen to 60% of 1943 levels. Production of 30mm ammunition, critical for bomber-destroyer units equipped with heavily armed FW-190 variants, had declined to less than 40% of previous capacity. The Mauser ammunition factory at Oberndorf suffered severe damage from an American bombing raid on April 20, 1944. Production halted completely for 6 weeks. When manufacturing resumed in June, output never recovered to pre-raid levels due to workforce casualties and damage to specialized machinery that could not be replaced. Similar attacks against other ammunition production facilities throughout Germany created cumulative effects that strangled fighter operations more effectively than direct attacks on airfields or aircraft factories. Fighters that survived combat returned to bases where ammunition to rearm them was increasingly scarce. By July 1944, some Luftwaffe fighter units were rationing ammunition, restricting pilots to single sorties per day to conserve supplies. American ammunition production, safely located in the continental United States far from any Axis bombing capability, continued expanding throughout 1944. Lake City Ordnance Plant reached peak production in 1944, manufacturing nearly 7 billion rounds of small arms ammunition that year, a production rate Germany could not have matched even with undamaged facilities and unlimited raw materials. The consistency of this vast production was its most remarkable feature. Ammunition manufactured in January 1944 functioned identically to ammunition produced in December 1943 or would be produced in September 1944. Lot-to-lot variations that German manufacturers accepted as inevitable simply did not exist in American production. June 6, 1944, D-Day. Allied forces invaded Normandy, supported by overwhelming air superiority that the Luftwaffe could not contest. German fighter units attempting to attack the invasion fleet found themselves outnumbered by factors of 10-1, facing American and British fighters whose ammunition supplies seemed inexhaustible. Luftwaffe combat reports from June 6 through June 8 documented the impossible mathematics of air combat when one side possessed both numerical and logistical superiority. German fighters that managed to reach combat altitude over the invasion beaches faced continuous defensive fire from ships, ground forces, and patrolling fighters, all using ammunition that worked flawlessly in all conditions. The 50 caliber machine guns mounted on Allied ships and ground vehicles used the same ammunition as aircraft guns, benefiting from the same reliability and consistency. This universal standardization meant Allied forces maintained suppressive fire continuously, creating an environment where Luftwaffe fighters could not operate effectively even when they managed to penetrate the fighter screen. July 1944 brought the introduction of fighter-bomber tactics by American P-47 Thunderbolt and P-51 Mustang units, which began strafing German ground targets when bomber escort duties did not require their presence. These attacks devastated German logistics, destroying trains, trucks, and supply depots with ammunition expenditure that German industry could never hope to match. A typical P-47 fighter-bomber mission carried approximately 3,200 rounds of 50 caliber ammunition distributed across 8 wing-mounted machine guns. Pilots could strafe targets for extended periods, making multiple attack runs against different targets during a single sortie. The ammunition reliability meant guns functioned perfectly even after sustained firing that heated barrels to temperatures that would have caused German weapons to malfunction. German logistics officers calculated that American fighters were expending more ammunition in ground attack missions during July 1944 than total Luftwaffe fighter ammunition production that month. This disparity rendered defense impossible. German forces could not move during daylight without risking attack from aircraft that seemed to possess unlimited ammunition and operated with impunity across the entire theater. August 1944 marked the first anniversary of the Schweinfurt raid that had initiated systematic German evaluation of American ammunition. The technical officers at Rechlin, who had examined that captured 50 caliber ammunition 12 months earlier, now prepared final reports documenting what German industry had learned but could not apply. American ammunition superiority derived from 3 factors German industry could not replicate under wartime conditions. First, automated production, using machinery designed for mass manufacture rather than craft production. Second, systematic quality control, using statistical methods that identified problems before they affected product quality. Third, standardization that eliminated variations between manufacturers, ensuring true interchangeability. German industry possessed the theoretical knowledge to implement these approaches. German engineers understood statistical process control and could design automated production equipment. What Germany lacked was the industrial infrastructure to apply this knowledge at the scale American production achieved, and more critically, the time and resources to build that infrastructure while simultaneously fighting a losing war on multiple fronts. September 1944 brought desperate attempts by Luftwaffe commanders to contest Allied air superiority through new tactics and weapons. Sturmbok units, flying heavily armed and armoured FW-190A-8 fighters, made massed attacks against bomber formations, accepting high casualties to achieve bomber kills that might force the Americans to suspend daylight operations. These attacks failed to achieve strategic results, despite occasional tactical successes. On September 27th, Sturm Group 4 lost 17 fighters while shooting down 13 B-17 seconds. The exchange rate, while favourable in aircraft destroyed, was unsustainable given the Luftwaffe's inability to replace experienced pilots and the Americans' capacity to replace both aircraft and crews within weeks. More critically, the Sturmbok units consumed ammunition at rates that depleted stockpiles faster than production could replenish them. The heavily armed FW-190A8 divided by R2 carried 4 20mm cannon and 2 30mm cannon, providing devastating firepower but requiring enormous ammunition expenditure per sortie. A single squadron making one combat sortie consumed more ammunition than German factories produced in a day. October 1944 brought the final collapse of organized Luftwaffe fighter defense over Germany. American bombers now roamed German airspace virtually unopposed during daylight, while German fighters husbanded remaining resources for defense of critical facilities and occasional spoiling attacks that might disrupt but could not prevent American operations. The ammunition situation had become critical. Luftwaffe ordnance officers issued directives restricting ammunition issue to operational necessities, prohibiting training flights using live ammunition, and requiring units to report daily ammunition consumption to higher headquarters. These restrictions, unthinkable earlier in the war, reflected the industrial defeat Germany had suffered. American forces, by contrast, faced no ammunition constraints. Training continued at full intensity with unlimited ammunition availability. Combat units received ammunition resupply faster than they could expend it. Some fighter groups actually requested reduced ammunition deliveries because storage capacity on forward airfields was exceeded by supply shipments. November 1944 brought reports from German intelligence services attempting to understand how American industry achieved the production levels German observers documented. Reconnaissance photographs of American ordnance plants showed facilities of staggering scale, with individual buildings larger than entire German manufacturing complexes. Lake City Ordnance Plant covered more than 3,000 acres and employed 40,000 workers operating around the clock in 3 shifts. The plant consumed raw materials at rates that exceeded total German brass production across all applications, military and civilian combined. Single production lines at Lake City manufactured more ammunition daily than Germany's total daily output from all facilities. German intelligence analysts correctly identified that America's automotive industry experience provided the foundation for this manufacturing supremacy. American companies like General Motors, Ford, and Chrysler had developed mass production expertise through decades of civilian vehicle manufacturing at scales Germany never achieved. These companies applied their expertise to ammunition production with devastating effectiveness. December 1944 brought Germany's final offensive in the West, the Battle of the Bulge. Luftwaffe fighters made maximum effort in support of ground forces, launching more sorties during late December than in any month since June. The operation consumed Germany's carefully hoarded ammunition reserves with minimal strategic effect. American fighter pilots, supported by unlimited ammunition resupply, destroyed Luftwaffe aircraft at ratios exceeding 10-1. P-51 Mustangs, armed with 50 caliber machine guns, proved more than adequate against the Bf-109 and FW-190 fighters Germany committed, while American ammunition reliability meant guns functioned perfectly in the brutal winter conditions that caused increased malfunction rates in German weapons. January 1945 brought the end of systematic German ammunition production. Allied bombing had destroyed or severely damaged every major ammunition manufacturing facility in Germany. Remaining production occurred in dispersed workshops, producing ammunition from salvaged materials with quality control that would have been unacceptable earlier in the war. Luftwaffe fighter units began reporting chronic ammunition shortages that grounded aircraft even when fuel was available. Pilots who managed to fly combat sorties returned to bases where no ammunition existed to rearm their aircraft for subsequent missions. The industrial defeat was complete. February 1945 marked the collapse of German air defense. The Luftwaffe could no longer contest Allied air superiority anywhere over Germany. American and British bombers struck targets at will, supported by fighters whose ammunition supplies never faltered. The 50 caliber Browning ammunition that German engineers had examined 18 months earlier at Rechlin now fell like rain across Germany, fired from thousands of aircraft attacking everything that moved. The consistency and reliability that had seemed merely impressive in August 1943 now appeared overwhelming, demonstrating industrial capabilities that defeated Germany as certainly as military operations. March 1945 brought German surrender negotiations in Italy and the Western Front, as organized resistance collapsed. Luftwaffe fighter units destroyed aircraft and remaining ammunition rather than allow capture. The ammunition they destroyed represented the final stocks from production that could no longer be replaced. American forces advancing into Germany discovered ammunition storage facilities containing 50 caliber rounds captured from downed American aircraft. German technical evaluations and test reports accompanied these stockpiles, documenting the exhaustive analysis Luftwaffe engineers had conducted throughout 1943 and 1944. These reports, recovered intact and translated by American intelligence teams, revealed that German experts had correctly identified American ammunition superiority and understood its sources. The reports noted manufacturing consistency, praised reliability, and acknowledged industrial capabilities Germany could not match. But understanding the problem and solving it proved fundamentally different challenges. April 1945 brought Germany's final collapse. Luftwaffe units that still possessed operational aircraft lacked fuel and ammunition to fly them. American fighters roamed German airspace unopposed, their 50 caliber machine guns ready but finding few targets worth the ammunition expenditure. May 8, 1945, Germany's unconditional surrender. Air war over Europe ended with Allied air forces possessing complete superiority, achieved through industrial capacity that had overwhelmed German technical excellence and tactical skill. The 50 caliber ammunition story represented in miniature the broader narrative of Allied victory: superior industrial organization, systematic application of proven manufacturing methods, and resource advantages so overwhelming that German countermeasures, however skillfully conceived, could not overcome the fundamental disparity. Post-war analysis by both American and German investigators confirmed what Luftwaffe engineers at Rechlin had concluded in 1943. American ammunition superiority derived not from secret technologies or revolutionary breakthroughs, but from disciplined application of mass production principles developed in civilian industry and transferred to military production with remarkable effectiveness. German ammunition, when manufactured under ideal conditions by skilled workers using proper materials and equipment, matched American ammunition in technical characteristics. But Germany never achieved the sustained consistency that American production maintained across billions of rounds manufactured over 4 years of war. Individual batches of German ammunition might equal or exceed American standards, but the batch-to-batch variations that American production eliminated through statistical process control remained endemic in German manufacturing. The lessons learned through examination of American 50 caliber ammunition influenced post-war German industrial development. When the Federal Republic of Germany began rebuilding its defense industry in the 1950s, engineers consciously adopted American-style quality control methods and statistical process control. They recognized that modern warfare required ammunition reliability that craft manufacturing traditions could not provide. The NATO standardization agreements that define ammunition specifications for Western alliance nations during the Cold War incorporated American quality control standards as requirements, not aspirations. Ammunition manufactured by any NATO member had to meet reliability standards that American 50 caliber ammunition had demonstrated during World War II: near-perfect consistency, functionally zero malfunction rates, and genuine interchangeability between manufacturers. The impact of American ammunition superiority extended far beyond the immediate tactical advantages it provided during World War II. It demonstrated conclusively that modern warfare had become an industrial competition, where systematic organization mattered more than individual excellence, where consistency trumped occasional brilliance, and where logistics determined outcomes as certainly as combat operations. German fighter pilots had been among the most skilled in the world, flying aircraft that often matched or exceeded Allied designs in specific performance characteristics, but they fought with ammunition that worked most of the time against ammunition that worked all the time. That difference, multiplied across millions of rounds and thousands of engagements, created an insurmountable advantage. The mathematics were brutally simple. American .50 caliber ammunition gave pilots and gunners confidence that weapons would function when triggers were pressed. German ammunition required pilots to manage weapons carefully, compensate for reliability issues, and accept occasional malfunctions as inevitable. In prolonged combat, confidence versus uncertainty determined who pressed attacks home and who broke off early to preserve ammunition for more favorable circumstances. The industrial disparity that ammunition represented extended across every category of military production. American factories produced more aircraft, more vehicles, more weapons, and more ammunition than German industry could match, while simultaneously maintaining high quality standards and greater consistency. This combination of quantity and quality proved decisive. The .50 caliber ammunition examined at Rechlin in August 1943 had told German engineers everything they needed to know about American industrial capabilities. Each identical round, manufactured to tolerances German industry considered impossible, represented a manufacturing system that could produce billions of rounds with the same consistency it brought to automobile production. The Luftwaffe fought bravely and skillfully throughout the war, achieving tactical victories even when strategic defeat was certain. But they fought with ammunition that reflected Germany's industrial limitations, while facing enemies equipped with ammunition that represented America's industrial maturity. In the end, that disparity mattered more than courage or skill. The story of American .50 caliber ammunition in World War II demonstrates the decisive advantage that industrial excellence provides when applied systematically at scale against opponents who lack the capacity to match or counter it. It illustrates how consistency and reliability, achieved through disciplined manufacturing processes, can overcome apparent technical sophistication that cannot be maintained in volume production. Most fundamentally, it shows that modern warfare rewards nations that master industrial organization as thoroughly as military operations. The battles are won by soldiers, but wars are won by factories. American ammunition production won the battle for air superiority, not through individual superiority of each round, but through the relentless accumulation of small advantages multiplied across billions of rounds that simply worked, every time, without fail. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.